Hi everyone, this is Natraj. I'm back with another video. In this video, I'm going to talk about that Cloud NAT Gateway, secure the private internet access to the compute engine using Terraform. Why use the Cloud NAT? The Cloud NAT is allow the resource in the private VPC network to communicating with external service securely without requiring any external IP address. Understand the benefit, we can see that one by one. First one is that security. The VM only need for that internet access to downloads and updating the package. Also that reducing the external threat and unauthorized access. Next one is that availability. The Cloud NAT is ensure that consistency availability by automatically distributing the traffic across the multiple instances to eliminating the single point of failures. Next one is that scalability. The Cloud NAT is dynamically scaling based on your network's traffic needs but without requiring any manual interruptions. Next one is that performance. The Cloud NAT does not reducing the network bandwidth per VM because that Google is advanced networking technologies. Next one is that logging. You can enable the logging for the Cloud NAT through VPC flow log features, which provide the details information about the traffic flows to and from your VM instance. Next one is that monitoring. You can integrating with the cloud monitoring tool. In generally, you can create the custom dashboard to visualize the key metrics such as network gateway usage, number of the active NAT connections and more. Types of Cloud NAT. These types of NAT is help you to managing the network traffic effectively while enhance the securities and reducing the cost associated with the public IP address. The first one is that public NAT. The main purpose is that allowing the instance without external IP address to access the internet. The second one is that private NAT. The main purpose is the same VPC network, each instance is communicating with each other using the private IP address without need for the external IP address also. Next one is the supported reviews. This table is provide the quick overview of the resource that can be used for public and private NAT on the GCP. So you can see things, the public NAT it be suitable for all the resource, whereas the private NAT is suitable for some of the things only. Architecture overview. Here the brief explanations of each component one by one in this diagram. First one is that compute engine VM. This is a virtual machine instance running on that GCP. Next component is that subnet. The VM is part of the subnet within the CRD block. The subnet is within that VPC network. The next component is the VPC network. The VPC network is logically isolation network in that cloud where you can create the different subnet. The next component is that cloud router. The router is dynamically routing the traffic within your VPC to exchange the routing information between the VPC and the on-premise network. The next component is the NAT gateway. The NAT gateway is allow the VM instance in the private subnet to be access the internet while keeping their private IP address. The NAT gateway has that own public IP address. Next component is the internet. The internet is accessible through the NAT gateway. We are at the Visual Studio Code. The entire source code is available in my repository. You can clone from anytime. This is my Terraform project. I am creating the GCP environment with the VPC, firewall role, compute instance and the NAT configuration. We can see the file one by one. The first one is that nat.t file. This Terraform code I am defining the Cloud NAT resource for my GCP. We can break down that code one by one. The first attribute is the naming. I am setting the name of my NAT resource. Next one is the router. I am associating that NAT resource with my cloud router. Next attribute is region. Here I am specifying the region where my NAT resource will be created. In my case US Central 1. Next attribute is that NAT IP allocated option. Here I am defined with auto only, which means that automatically allocating the IP address. Next attribute is that source subnet IP range to the NAT. Here I am defining the value called all subnetwork all IP range, which means that I'm specifying that all the subnet IP range will be translating to by their NAT. Next attribute is that min port per VM equal to 24, which means that I'm setting the minimum number of the port can be to be allocating per VM. We'll be moving to that instance.tf file. The first resource is that Google Compute default service account. In this block, I'm retrieving the default service account for my specific project. Next resource is that Google project IAM member. This resource I'm assigning that osconfig.guest policy admin role to my default service account. This role is main purpose of managing the OS configuration as well as my policies. Next one is that member attribute. Here I'm specifying the member to the role, assigning for the data source for my default service account. Next resource is that Google project IAM member. In this resource I'm assigning that compute.instant admin.von role. This purpose of role is managing the compute instance completely. Next resource is that Google compute instance. This configuration I'm setting for Google compute engine with the specific instance types, zone, metadata, service account, booting disk, startup script, network interface and tags and so more. We can see the detailed explanation of each attribute one by one. First one is the naming. I am setting the name of my instance. Next one is that machine types. I am specifying the EC2 micro because it's a cost effective instance. Next one is that zone. The instance will be created under the US Central 1. Next one is that allowing stopping for the update. I am allowing for the instance to stop for my update. Next one is that metadata block. Here I am setting the key value pair for my instance behaviors. I am enabling the two attributes. The first one is that enable guest attribute. This purpose of guest attribute is providing that instance information about my running time environment as well as for my configurations. Next one is that enable OS configuration. The main purpose of the OS configuration, you can installing the package or applying the security package through VM manager service. Next one is the service account block. Here I am using the default service account and granting the full access to my cloud platform. Next one is that booting device. This configuration is ensure that instance is booting the instance, initializing that Ubuntu 22 LTS operating instance. Next one is the metadata startup scripts. This block I am running that scripts when the instance starts. I am installing the couple of package. OS configuration agent is essential for managing the OS policies such as package installation and configuring the software and more. Next one is the network interface. This block I am referring the network setting for my instance. You can see here the network attributes. Here I am referring that VPC network which is instance will be that connected. Next one is the subnet. Here I am specifying the private subnet within my PPC. Access underscore config, this is a block is required for assigning that external IP address. Next one is a tag I am defining with my private instance name. So we'll be moving to the firewall.tf file. These firewall rules are designed to managing the traffics for my instance. I written the two rules. The first one is that allowing the ingress via NAT. This rule is allowing the outbounding traffic to my intranet. The second rule is allow the return to the traffic. This rule is allowing the inbounding traffic from the internet. So moving to the router.tf file. The Google Compute router resource, it is used for dynamically exchanging the routing the traffic between the VPC and the Cloud NAT service. You can see here the networking attributes I am defining my VPC ID. The next file is that variable.tf file. The variable block I am specifying the Google project ID. Also I am defining my default value of my project ID here. The next one is that vpc.tf file. The first resource is the Google Compute Network. I am declaring the VPC network resource here. The one of the parameter called auto create subnet equal to false, which means that I am disabling the auto creation of the subnetwork. The next resource is the Google Compute subnet. I am creating the public subnet with that IP range of 10.0.0./24. There is no private IP access enabled for the Google service. The next resource is that Google Compute subnet. Here I am trying to create that private subnet with the IP range of 10.0.1.0/24. Here I am enabling the private access for my GCP cloud. Now I am moving to the terminal to execution the entire operations. I am going to click on the three dots, new terminal. Just I am executing the Terraform plan command to validate my all the syntax. Also that executing the Terraform init command to installation the all the plugins. I am ignoring the Terraform init command because I am already installing the entire things. Directly I am executing the Terraform plan command. You can see here the 10 resource going to add, 0 changes, 0 destroyed. Now I am going to executing with the Terraform apply command. So I am providing the yes is input. Now the resource creation is going on. My Terraform operation successfully completed. We'll be moving to the GCP console to validate my all the resource creation part. Now at my GCP console, I'm choosing with my PCB project ID. Now I'm going to my VPC. I click the VPC networks. You can see here is my VPC is created, 2 subnet and 2 firewall rule is associated. Now I'm going to the NAT gateway. Yes, NAT gateway is visible. Also you can see the status is showing as the running. Now I'm going to that my VM. See, to test that NAT gateway, you have to create the one jump server. From the jump server to connect with the test instance. From the test instance, you can try to executing that some curl command to validate my any website, so that you can come to know whether it is a NAT gateway is working or not. But in my case I am tried with a different way. Just I am clicking that test instance. From that my agents I am sending that OS information to that my OS info page. So you can see here this OS information is completely visible. This is a way also we can validate my NAT gateways whether it's working or not. So that's all this video. I hope this video will be useful to everyone. Thanks for watching. Bye.